Hello and welcome to another video. We are continuing with algebra. We've done expansion of algebraic factors in the last video, and we've also done simple expansion of algebraic expressions with brackets. Today, what we're talking about is factorizing. Now, factorizing is the opposite of expansion. What you simply end up doing is you saw brackets in the last video and the video before that. So, what I'm going to try to do now is to have expressions like this, and I would want to put them into brackets. Okay, so that's the purpose of factorization. Now, the first thing that you need to learn is in factorizing is finding common factors. Okay, let's read what this says. It says common factors are factors that are in more than one term. For example, 3xy and 9x cube. In 3xy and 9x cube, there is 3 common. So 3 is a factor of both. What I mean by factor is that when I divide 3 by each of these, divide each of these terms by 3, it cancels out. Okay, and when I divide x by these two terms by x also cancels out. Okay, so x is common to both and 3 is common to both. How is that an advantage to me when I'm closing brackets? Let's look at that. It's the reverse process of expanding. That's what I called this before. The expression x square minus 6x can be written as the product of two factors. What I've done is when I do x square minus 6x and I think about common factors, I see one is x. There's no other factor that's common. There's one common, but I don't write that down. Okay, because one is a negligible number of when you're factorizing. So when you factor out an x, you end up dividing every term by x. So if I divide x square by x, what am I left with x? And the minus remains as it is. And 6x divided by x just leaves me 6. The idea is that if I were to expand this, I'm going to go get that original expression back. And that is enclosing in brackets, honestly. Okay. When we factorize this, we get similarly 4x plus 2. You could factorize 2 out of it. Xy minus x, you could factorize y out of it. In some expressions, we may fail to find a common factor for all the terms. However, you may still be able to factorize if we can find a common factors for each pair of terms. We'll talk about this. Okay. To fully factorize this, the common factors are we'll talk about I'm just going to write this down for you and then solve it for you. So let's say 6xy minus 15y. Now I know that 6 is not common to both of them and 15 is not common to both of them, but 6 has a factor 3 which 15 also has. So I could essentially factor out a 3. Okay, there's also y common to both terms, so I could factor out 3y. What happens when I divide this term by 3y? What am I left with? If I divide this term by 3y, I'm left with 2x. 6xy divided by 3y will give me 2x. Okay, that's what I think about mentally. Okay, 15 divided by 3 leaves me with 5, and y divided by y leaves me with 1. So I won't write anything else, and that's the factorized form of this. Let's apply that to a couple of questions. Let's look at this. Of course, 12 is not common to both of 12 and 16, but there's a common factor 4. Okay, and is a letter common? No, I don't see any letters common. So what happens when 12p is divided by 4? I'm left with 3p minus 4q. That's the complete factorized form of 12p minus 16q. Okay, let's talk about the next one then. 21 and 14. What is the largest common factor that 21 and 14 have? 21 and 14 go into 7's multiples. Okay, so I know that 7 is common. We write 7. I see z power 1 and z square, which means that there's a z common as well. So I'm going to write a z outside as well. What happens when 21yz is divided by 7z? So 21 divided by 7 leaves me with 3. And yz divided by z leaves me with y. 14 divided by 7 leaves me with 2. And z square divided by z leaves me with just z. Okay, that's the complete factorized form of this. There's 3 terms. Typically, for factorizing 3 terms, there's a separate topic. But here I am just talking about taking a common. Let's see what's common to all of them. I see that 75, 100, and 50 are all multiples of 25. And I have x square, and x. So all of them have x power 1. That's common to all of them. and y power 1, that's common to all of them. So it's 75 divided by 25, that gives me 3. And in the first term, I have x square y square. And I've taken a xy factor out common. So x square y square divided by xy gives me xy 4. 100 divided by 25, and x square y divided by xy gives me x, and y goes out. Okay. And minus 2. I'm left with no x's and just y's. Okay. The idea is that if I were to multiply all of these across again, okay, I would end up with these same numbers that I have here. Okay. xy minus 2y square x. So I factor out an x and I factor out a y as well. So I'm left with xy divided by xy leaves me with 1. Remember that it doesn't leave out a 0. Okay, 2 is added as it is, and I have y because the x got factored out. Okay, I can multiply again and see if I have the right answer. Okay, I have a common, I have b common. Okay, abc divided by ab gives me c, and 4 as it is, a square b divided by ab, so a. What is left? A square b divided by ab. Okay, so b cancels out in a. X square can be factored out, 1 minus 3y. What can I factor out from here? 5. And I can also factor out n. 2n plus 1. Okay. I can factor out a 2. I can factor out an x. I can factor out a y. I can factor out a z. So z plus 2 times 4 divided by 2 is 2. X square, y square, and z. X square divided by x leaves me with x. Y square divided by y leaves me with y, and z square divided by z divided by z leaves me with nothing. So 2xy. Then I can factor out a 2. I can factor out okay. I'm left with nothing here. 1. 4 divided by 2 gives me 2. A square divided by a gives me so I'm left with 2. A square divided by a gives me a. B square divided by b gives me b, and c. Okay. What I want you to also now notice is that you will have very similar past paper questions as well. So this says factorize completely 4xy minus 6xz. So I see 2 is common and x is common as well. 2y minus 3z. Okay. 6 divided by 2 gives me this, and x divided by x gives me enough 1, and the z is added as it is. Okay, we can have more past paper questions as well. So 7 is common to both of them, a is common to both of them. So 7ac divided by 7a gives me c only. 14 divided by 7 gives me 2, and a divided by a leaves me with 1. So that again 12 and 18, 6 a and x. 2x plus 3 a square. Okay. Then this is a specific topic that appeals to this identity that I talked about before. Now, this is called the difference of squares, and it's a very common past paper question that you're going to see. We're going to do a couple of examples here as well. So let's look at this. Okay. This is when The first and the second term, there are just two terms in the expression. That's one thing that you need to notice, and both of them have to be perfect squares. What I mean is that they could you could take a root and end up with a possible um, whole numbers as answers. Okay, so here I notice that 1 is also a perfect square and 25x square is also a perfect square. So 1 is the square of 1 and 25x square is the square of 5x. So the first thing that I could do is write it like that if I want. So I know exactly. And then this translates to what? This translates to a plus b into a minus b. So 1 minus 5x, 1 plus 5x into 1 minus 5x. It doesn't matter which one you write first, but because it was written like that, that's why I've written it first. Okay. Similarly, this is the square of 3y, and this is the square of 4x. 3y plus 4x and 3y minus 4. Now this here is to show you that this only works when you have a negative sign in the middle. There's no negative sign in the middle, so cannot be factorized. Okay, one thing that's important that you need to notice. The second thing that you need to notice is this. Now notice that I cannot write 2x whole square, and I cannot write 8 as a whole square. I cannot really write root of 8 whole square. It would be wrong. Okay, so this can't go into a difference of squares right now. But what I see is what I've learned in the previous topic, and that is that I could take common. What is common to a 2x square minus 8? 2 is common. I could write that as 2 bracket x square minus 8, x square minus 4. Now I see a difference of squares. So this is x square, it's 2 square. Okay, this could be factorized to, yeah, it doesn't matter if you write a bigger bracket, but I'm just trying to show you. So the bigger bracket doesn't make a difference because it's just going to open up and look something like this. Okay, xy squared, xy plus 2z and xy minus 2z. Okay, I could factor out to 2, 9 minus x squared. And then say that this is again set of perfect square. Okay, because 18 wasn't a perfect square, I had to factor out to 2. I see that here as well. While 16 and 4 are perfect squares, this x and x cube won't fit into squares. But I see is there's something common to both the terms. That's 4. And there's an x. And there's a y as well. So I'm left with 4y squared minus x squared. So I can write that as 4xy 2y minus x and 2y plus x. Okay, now a practical application of this, I've never seen this on the past papers, but this is something very useful when you're calculating mentally. And it's not just for this number, but easy numbers as well. Use the difference of two squares to find without a calculator the value of 139 minus 129. Now see this. So I have 139 plus 129. And 139 minus 1. Okay, because both were perfect squares. This is an easy 10. Let's add a 139 and 129 on this side. 862 268. So 2680 is your final answer. Okay, I'll be back with another video on factorizing. We will learn about factorizing by pairing and then factorizing quadratic expressions in the next video. Thank you for watching.